Hello, and thank you for joining us. Today's webinar is Introduction to EPA Methods 524 Series 101. Our presenter is Jeremiah Bradley, Applications Chemist for Teledyne Tekmar. We will be taking questions at the end, so please feel free to submit questions throughout the presentation. This webinar is being recorded and will be available within a few days. Okay, now I'm going to turn it over to our presenter, Jeremiah Bradley.
Hello, everyone, and thank you for joining me with what I hope will be a great resource for introducing EPA Method 524 Series 101. With today's topic being over Method 524, I would like to briefly introduce you to Purge and Trap and talk a little bit about the EPA Method 524 before I go over the core differences of each method and how they progress with each provision, specifically 524.2, 524.3, and 524.4. If you have any questions, feel free to type them in below and I'll try to answer them towards the end at the best of my ability. To begin, let's start off with what is Purge and Trap and how it works. First, a sample is collected, sealed, and stored using a 40 milliliter VOA valve. The sample is later purged with an inert gas, causing the VOCs to be swept out of the sample matrix and deposited on an analytical trap. Then, upon desorb, the trap is heated and the VOCs are swept to the GC by backflushing the trap with the GC carrier gas into the column. The GC column then separates the concentrated compounds as they are carried to the mass spec detector for analysis, thus making the Purge and Trap an excellent and efficient sample introduction technique for EPA Method 524. So what is EPA 524 series? There are a set of EPA methods used for the determination of purgeable organic compounds in finished drinking water. It's capable of determining selected analytes with precision and accuracy from reagent water, groundwater, and surface water sources. This series is commonly used in water quality laboratories to monitor targeted compounds within related matrices or sources. I do want to point out that 524.2 specifically is for all stages of drinking water production and treatment, and that method 524.3 does not replace 524.2. In this webinar, I will take some time to briefly discuss the method QC requirements, the equipment involved, and a difference and similarity between each revision. As I mentioned before, the original purpose of creating the 524 series was to analyze VOC in drinking water as an investor response towards the Safe Drinking Water Act. This is one of the many methods the EPA has used as a strategy to monitor and report possible contaminants in drinking water from rivers, reservoirs, and groundwater well sources. To accommodate for the various improvements made in Purge and Trap and mass spec detector technology, several revisions were made in 524.2, leading to the current revision we have today. Again, it is important to note that 524.3 is not a replacement for 524.2. 524.3 was introduced to allow flexibility of the method parameters and analysis. This flexibility includes allowing the use of single ion monitoring, or SIMS, to target emergent contaminants of interest and troubleshooting some compounds, the troubleshooting ones that are complicated to sometimes find or identify. Target compounds of interest were updated to include reformulated gasoline additives and potential breakdown products of MTBE. At the same time, poor performance were removed along with other harmful practices like hydrochloric acid as a preservative. With the new reformative allowing for more Purge and Trap flexibility, we're able to see an increase in throughput and purge efficiency. Naturally, this requirement for QC definition to be updated as well to control acceptable range, and we'll talk more about this in the updates in the upcoming slides. And lastly, 524.4, the biggest difference between 524.4 was the incorporation for the use of nitrogen as a purge gas. An extensive study was done to show the use of nitrogen still retains Persian trap efficiently as a Persian gas alternative while allowing you to save on helium resources. The updated method also includes a recommendation for alternative traps to use as you may experience some difficulties with recoveries in comparison to helium. Here's a quick overview of the changes between 524.2 and 524.4, along with some of the major differences. At first glance, there's a few big differences you'll notice between method 524.2 and 524.3. First being the sample volume. 524.2 recommends 25 milliliters, and you can use 5 mils depending on the sensitivity, but 524.3 requires strictly 5 mil samples. The desorb times are optimized and recommended for 2-minute desorb time, whereas before in 524.2, the 4-minute desorb time cannot be changed. The GC column recommends inner diameter requirements as well, which you can see here in comparison. Lastly, with nitrogen being used as an alternative for a purge gas, 524.4 recommends using trapped ions containing synthetic carbon absorbance media, so Silco or your Valco 3000, or equivalent carbon-based traps because the traps containing the Tenax or the silicon gel in coconut charcoal may yield lower recoveries when compared to helium purges. Here's a convenient table showing the modification parameters both recommended and allowed for 524.3 and 524.4. All methods recommended a purge gas flow of 40 milliliters per minute, but 524.2 was a little stricter in that the purge had to be for 11 minutes and the desorb had to be for 4 minutes. You cannot change these parameters. 524.3 and 524.4, however, allows for more flexibility to modify your purge and trap condition. Here we can really see that and compare the 5 key parameters which allow users to optimize their ideal purge and trap parameters. The box highlighted in yellow demonstrates the difference in 524.3 and 524.4 recommended range and allowable range when using nitrogen. And here's a convenient table outlining the analytical equipment involved in 524.3 and the recommended requirements for your review. I wanted to take the time to point out a few of the key hardware and requirements set for 524.3. Standard hardware includes a chiller for temperature-sensitive samples and must be set at 10 degrees Celsius or lower, but not frozen. Samples cannot be held for more than 14 days after collection, too. When analyzing chlorodifluoromethane, trap 3 and trap 10 cannot be used due to trapping efficiency. It simply does not have the sorbent to hold. The software should also allow for a calculation of the response factor or construction of linear or second-order regression calibration curve. Calculations of response factor statistics, too, such as the means or standard deviation, and the calculation of concentration of analyte using the calibration curve. Another keynote to observe is with the permissive use of SIM, you cannot use it to identify trihalomethanes. The BFE tune criteria. So the BFE tune criteria was revised for 524.3 and 524.4. It was revised from running every 12 hours in 524.2 to once prior to calibration in 524.3 and 524.4. Those highlighted in yellow demonstrated the change made between the two methods. Looking at a quick comparison, you can see that the mass ion 50 and 75 were removed and that both mass ion 175 and 177 acceptance criteria window was expanded to increase the passing credentials. Here's a list comparing the targeted analytes that were removed and added in 524.3 and the reason why. As we briefly mentioned before, and you can see in 524.3, we've removed some ketones, alkylates, and nitriles, including nitrobenzene, mainly due to the fact that they were non-regulated drinking water contaminants and non-carcinogens. Because we have no or because they have also poor purge efficiency, they were also removed. To the right, you can see a reformulated gas additives were added, including TBA and ethers. Other targeted compounds of interest were added into the list, including MCBE byproducts and chlorodifluoromethane. Per each method is a detailed platform of the method QC requirements that has to be followed to assure and justify the integrity of the instrument and sample analysis. This table demonstrates the core requirements of EPA method 524.2 and is here for your review. The main difference I wanted to point out here that you will notice is the comparison of 524.3 and 524.4 is the MDL being replaced with the MRL, or minimum reporting level, to calculate the upper and lower prediction interview of results. As I said before, in the QC guidelines, the MDLs are no longer required and were replaced with minimum reporting limits. It is defined as the lowest concentration and such that the probability of recovery between 50 and 150 is at least 99%. In the core aspect of monitoring and reporting, these are the core principles that are important in QC guidelines to justify that sample integrity was maintained throughout the schedule. There's also the pillar for troubleshooting when a problem may occur, helping you identify when it may occur when you're reviewing your analysis. Here is the QC guideline for 524.3 and 524.4, listing all of the criteria and terms you should become familiar with for your review. Here you can see the criteria that was replaced the MDLs of the EPA method 524.2, requiring that the lower prediction interviews have to be greater than 50% recovery and the upper less than 150% within at least 7 replicates. In general, we use these terminologies in QC requirements to monitor and evaluate the integrity of the system. Using these guidelines, we're able to assure the quality of the instrument remains consistent throughout the scheduled sample analysis. Sample preparation and preservation. Prior to analysis, usually upon being filled with a sample, is treated for pH level and dechlorination. As I mentioned previously in 524.3, hydrochloric acid was replaced due to the hazard risk it proposed in usage. Here's a convenient table with brief details summarized in the sample handling. I also wanted to take the time to list a couple of helpful conversions for calculating some of the basic equations used to make standards or identify targeted calculations. So you'll be able to convert some of your basic units of ppm to nanograms per microliter and identify some of the targeted analyte concentrations when doing the math. These are very helpful if you ever use Excel, for example. And as far as challenges, the methods are pretty easy to use and adapt to in the lab. Challenges you may face are due to the environmental impact causing background levels and sample contamination. This is especially common with methylene chloride, acetone, and carbon disulfide. You may also experience some water vapor coeluting or impacting your sensitivity and peak shapes. And these are also issues that can be addressed and corrected through within your Purge and trap parameters by optimizing your settings. Any questions? Well, with that, thank you for attending this webinar. If you have any questions, feel free to list them now. If you'd like to see a 102 of this webinar covering analytical data with an in-depth look at parameters effects, or have any suggestion webinars that you'd like to see, feel free to email me at the email below. And with that, I hope you enjoy the rest of your day.